Screw gauge. Screw gauge is an instrument that can measure the dimensions up to 1 by 100th of a millimeter or 0.01 millimeter. With the screw gauge, it is possible to measure the diameter of a thin wire and thickness of thin metallic plates. Description of screw gauge. The screw gauge consists of a U-shaped metal frame. A hollow cylinder is attached to one end of the frame. Grooves are cut on the inner surface of the cylinder through which a screw passes. On the cylinder, parallel to the axis of the screw, there is a scale which is graduated in millimeter. It is called pitch scale. One end of the screw is attached to a sleeve. The head of the sleeve is divided into 100 divisions and it is called the head scale. The end of the screw has a plane surface, that is spindle. A stud or anvil is attached to the other end of the frame, just opposite to the tip of the screw. The screw head is provided with a ratchet arrangement, that is safety device, to prevent the user from exerting undue pressure. Using the screw gauge, first you find out the pitch of the screw. The pitch of the screw is the distance moved by the tip of the screw for one complete rotation of the head. It is equal to 1 millimeter in typical screw gauges. Pitch of the screw equal to distance moved by the pitch by number of rotations by head scale. Next, least count of a screw gauge. The distance moved by the tip of the screw for a rotation of one division on the head scale is called the least count of the screw gauge. Least count of the instrument equal to value of one smallest pitch scale reading by total number of head scale division. LC equal to 1 by 100 equal to 0.01 millimeter. Zero error of a screw gauge. When the movable stud of the screw and the opposite fixed stud on the frame area brought into contact, if the zero of the head scale coincide with the pitch scale axis, there is no zero error. Positive zero error. When the movable stud of the screw and the opposite fixed stud on the frame are brought into contact, if the zero of the head scale lies below the pitch scale axis, the zero error is positive. Here, the second division of the head scale coincide with the pitch scale axis. Then the zero error is positive. Zero error equal to plus n into LC, where n is the head scale coincidence. In this case, zero error equal to plus 2 into 0.01 equal to 0.02 millimeter. So the correction is minus 0.02 millimeter. Negative zero error. When the plane surface of the screw and the opposite plane stud on the frame are brought into contact, if the zero of the head scale lies above the pitch scale axis, the zero error is negative. Here, the 97th division coincide with the pitch scale axis. So, zero error is minus 0.03 millimeter. The zero correction is plus 0.03 millimeter. Measuring mass. Different measuring devices have to be used for items of smaller and larger masses. First one, common or beam balance. A beam balance compares the sample mass with a standard reference mass. This balance can measure mass accurately up to 5 gram. Physical balance. Physical balance is used in labs and is similar to the beam balance, but it is a lot more sensitive and can measure mass of an object correct to a milligram. Digital balance. Digital balance is easy to handle and commonly used in jewelry shops and labs. Spring balance. Spring balance helps us to find the weight of an object. Accuracy in measurements. Accuracy represents how close a measurement comes to a true value. Accuracy in measurement is centered in engineering, physics, and all branches of science. It is also important in our daily life.